Tonight we're going to dive a little deeper into our statistics chapter, and we're going to focus tonight on types of different statistical studies. And what we're about to find out is there's three big main types of statistical studies that we're going to focus on. Number one is an observational study, two is a survey, which is a specific type of observational study, and the third one is an experiment. But before we get started, I want to kind of throw out a teaser here. And perhaps, whenever we kind of do a study, in this day and age, we really can't pick up a magazine or read an article online or, really turn on the TV and watch the news or listen to the radio without being bombarded with, a study about this and a study about that. And naturally, the question arises, which studies do you trust and which ones do you have confidence in? And ironically, in 1936 is maybe the most famous case of a study gone wrong. And the Literary Digest was perhaps the most preeminent magazine of the time in our country. Very well respected. And they had predicted before the presidential election in 1936 that the Republican, Alf Landon, was going to win in a landslide over Franklin Roosevelt. And in fact, on the day of the election, just the opposite happened. And Roosevelt ended up winning in a monster landslide. And that bad prediction by this magazine eventually led to their demise, and they went bankrupt. So tomorrow we're going to take a look at some specific incidences as to why the study went bad. And they spent a lot of money, and they had about 2.5 million people participate in the study. And you're thinking, how could that go bad if you have 2.5 million? But boy, did it go bad. I think in general, you probably understand a lot that goes into a statistical study just from your own life experiences, and you bring that with you as you step into the classroom. But in general, regardless of whether it's a survey or some kind of experiment or whatever, here's a four-step process that generally follows. You start by asking a question that can be answered with data. It's all about data. We got to collect data, and that's where it leads us into number two. We're going to collect it as fairly and unbiasedly as possible. And then we're going to organize and analyze. How do we interpret this data? What is it trying to tell us? And then we're going to arrive at our conclusion. Some kind of definitive statement, a summary of what we've learned by collecting and analyzing the data. All right, it's time to put on your hard hats and tighten those bootstraps because we're about to plow through some monster definitions here. And as always, if we get to running a little too fast here, by golly, hit that pause button and do what you got to do. But there's three main different types of statistical studies, and number one is an observational study. Okay, and then number two happens to be a subset or a specific type of observational study, and that's a survey where we're going to go out and ask some questions, which presidential candidate do you favor and things like that. And the third one is an experiment. And our goal tonight is to not only define these three types of studies, but to really be able to differentiate between them and look at a bunch of examples and figure out why it's observational or why it's a survey or why it's an experiment. So our first definition says that an observational study records the values of the variables for members of a sample. Now, observational studies are designed to, check this out, observe. Sit back and observe the subjects as they are. Okay? And basically the key is we're doing this without any manipulation. Or another word that we're going to use a lot tonight is treatment. So we're doing this without any manipulation or treatment of the researchers, or by the researchers. So we've introduced you to some buzzwords we're going to see over and over again tonight. Now, what's a survey? A survey is a special type of observational study that gathers data by asking people a bunch of questions. So we gather data by asking people a series of questions. These are very, very common. We see a lot of surveys in our everyday experiences. All right. Now, what is an experiment? This one's very, very important. And this one assigns subjects to treatments. Now, what the heck is a treatment? Well, basically, we assign these treatments to see what effect the treatments have on some response. So maybe, I don't know, maybe you're trying to figure out, what effect does sunlight have on plant growth. And you take all these plants and you put 10 of them in the dark for the day, you put another 10 with limited sunlight, and then you put another 10 with full sunlight. And the treatment variable there is the amount of sunlight they're receiving each day, and you have control over how much sunlight each group is getting throughout the day. But I want to do now is I want to kind of put it all together, and I want to sketch a big Venn diagram that shows you the relationships of these different studies. Okay, the big one that I have experienced is the experiment one. This is a biggie. Okay, now separate from an experiment, and notice I'm going to try to draw this circle without any visible overlap here, is some kind of observational study. And a subset of an observational study is a survey. Okay, so in other words, all surveys are observational, but not all observational studies are surveys. We're going to reword some of the things we just said in case this clicks and makes more sense to you. But here are our key points of emphasis that we want to focus on here tonight. Now, an experiment is way different than an observational study, and it goes without saying. But within an experiment, subjects are assigned to treatments. And maybe we're trying to figure out if this new drug, lowers your blood pressure, and you bring in 50 people to the study, you split them in half, 25 get the real drug that you're testing, and the other 25 get a fake sugar pill called a placebo that they think is the real drug, but it's not. And so the treatment would be that new drug they're testing, and with the purpose of seeing what effect the treatment has on some response. Did the patients in this experiment lower their blood pressure? Compare that to an observational study where we're making no attempt to affect the outcomes. And in other words, i.e. here, there's no treatment given. We're just sitting back, chilling, and observing the people within our sample. This next statement we've got cooking here might be the most important one of the night. Let me see if we can pull out a few stars here. We'll star this one and make it stand out. But random sampling. This is so important, guys, and this goes back to that story I want to tell you about the 1936 presidential election. But random sampling of subjects is important in statistical studies in order to eliminate what? What are we trying to eliminate? I bet you got it now. We're trying to eliminate bias. So that the sample results may be generalized to the population from which the sample was taken. Now, this is the first time we've really introduced you to, what is a sample versus what is a population, and we're going to get into more detail in future videos. But basically, if you want to poll everybody on their favorite presidential candidate, you really can't hit everybody in the country, okay? And so, if the population is every U.S. citizen within the country, and you admit that you can't really question every single person, then what you're going to do is you're going to try to create or pick a random sample of people, and maybe you pick 1,000 people randomly, you quiz those random 1,000 people, and then you generalize your results and say, I think the entire country is going to vote for so-and-so. Now, this idea of studying cause and effect is huge because a lot of times when you create a statistical study, your end goal is to identify a certain cause and effect between two variables. You're saying variable X causes variable Y, and that's your end result, the conclusion that you hope to have at the end of the study. However, I want you to consider this. An observational study indicated that extensive use of a cell phone is linked to brain cancer. The problem here is, and what we're going to basically say and learn here tonight, is that an observational study can never conclude with a definitive cause and effect, okay? In other words, just because we sit back and observe it doesn't mean that we can definitively say that people who use a lot of cell phone time will automatically, get brain cancer. And the key here word is linked, but there's no definitive cause and effect. And there's what we call lurking variables, okay? People that tend to extensively use their cell phone, on the average, tend to have very stressful jobs. People that have stressful jobs tend to have, very inconsistent diets and some poor eating habits, perhaps, which leads to overall poor health, which then may be linked to brain cancer. But there's other variables in between the cell phones and the brain cancer. So basically, our conclusion here is that the main disadvantage of an observational study is that a cause and effect conclusion cannot be drawn. Okay? However, and this is worth starring here, when we do an experiment, just the opposite is true. Okay? When you do an experiment, and if you design it right, then you can conclude. Okay? Let's say that you can conclude a cause and effect relationship. If I could spell it right, that would help. You can conclude, and that's with experiments. And that's, generally speaking, observational studies are easier to perform, but like we said, the disadvantage here is that you can't use a cause and effect conclusion. However, now experiments, they're usually harder to set up, they take more time and energy to carry them out, but your conclusions in the end are more definitive. We're going to jump into some live examples tonight. And our big goal tonight is to take a look and try to identify these studies as a survey, an observational study, or an experiment. And if it is an experiment, we're going to try to identify what the treatment and response variables were. Looks like I need to move this down. There we go. All right. Now, this is a very long-winded story, and I certainly wouldn't expect you to copy it down word for word, but maybe you can generalize it a little bit here and write down some of the key aspects here. But we said Karen Allen, a researcher at the University of Buffalo, found that couples who own cats and dogs have more satisfying marriages and are less stressed in general than those who don't own pets. Now, pet owners also have more contact with other people, with each other and with other people. Allen compared 50 couples who owned either cats or dogs with 50 pet-free couples. The volunteers completed a standard questionnaire assessing their relationship and how attached they were to their pets. They also kept track of their social contacts over a 2-week period. To see how the couples responded to stress, Allen monitored their heart rates and blood pressure while discussing sore subjects. Pet-owning couples started out with lower blood pressure readings than the others, and their numbers didn't rise much when they argued. So basically, we're looking at, is this an experiment or is it more of an observational study and a survey? Here's the key, and I'm going to say this is an observational study with some surveying threads scattered throughout there. But it's observational. And here's the key. So she compared 50 couples with pets with 50 pet-free couples. Now, she didn't randomly select 100 people and then manipulate which ones were actually going to have pets and which ones weren't. She just basically observed which ones had pets, which ones didn't. And she just, through the questionnaire would indicate that there's a survey also taking place. But everything else was just observe the whole time through. Now, if you were on the fence with the last one, I think this one's going to clear it up when you compare the two. There was a study in Finland, and researchers randomly gave 857 healthy children in daycare centers xylitol in syrup, gum, or in lozenge form. Or they gave them a placebo, or basically that's like a fake gum or syrup in 5 doses per day for 3 months. According to the report in the October issue of the Journal of Pediatrics, the incidence of ear infections were reduced by 40% in children given xylitol chewing gum, 30% in those given the syrup, and 20% those given the lozenges when compared to children given the placebo. So this is a slam dunk right here. This is an experiment. And the reason is, you'll notice we're splitting the children into 2 groups basically. And within those 2 groups, one of them is getting the real thing, whether it's a syrup, a gum, or a lozenge, and the other group is getting the fake one. And so you're manipulating the 2 groups here. Now the treatment variable here, I'll abbreviate variable, okay, is the xylitol. I think I'm just guessing. I hope I'm pronouncing that correctly. And basically that's a variable because some people are getting it and some people aren't. Now the response variable, what we're trying to measure at the end of the day, is the incidence of ear infections. Okay? Did this drug, xylitol, have any effect on reducing the amount of ear infections the children were getting? So at the end of the day, we're trying to measure the ear infections to see if it went down. Another example here. We've got a college statistics class called Stat 113. And the Stat 113 instructor announces a study session to be held the night before the test. The instructor lists the students who attended the session and compares their scores to the remaining Stat 113 students' scores who didn't attend. And what type of a study is this? And I'm going to argue that this is an observational study. All right. This professor, he did not dictate who went into what group. Okay. It was an open study session. Anybody that wanted to come could come. And he's just simply writing down the names and observing their scores compared to the other students' scores. And there was no attempt by this professor to influence their responses. So that's strictly observational. I think that might be worth writing down. There was no attempt to influence their responses. It was just an open study session. Anybody that wanted to come could come, and then we compared their scores. A similar study here, perhaps, to determine whether a review session will improve his students' test scores, a Stat 113 instructor divides his class into two groups. He then requires one group to attend the study session and compares the test results to the other group that did not. And now we've got what we call an experiment. Maybe the professor is starting to wonder, is this extra study session, valuable? Is it worthwhile? Does it actually help? And so the professor himself is dividing the class into two groups. Okay, and so he is affecting their responses that way, and he requires one group to attend the study session. So that would be the treatment variable. And I'm going to abbreviate it this time since we wrote it out last time. The treatment variable is the study session. Some got it, some didn't. Study session. All right. Now the response variable here is going to be their test scores. How well did they perform on the test? Was there any noticeable difference? This is a fantastic multiple choice question. And generally, this topic that we're covering tonight more or less likely seems to be a multiple choice question on the exams. And this is an excellent example. And I would ask you to please hit the pause button at this time and try to sort through this question on your own and make a prediction. And in fact, even better yet, try to go through all four choices and classify each of the four as an observational study, a survey, or an experiment with a brief explanation justifying your answer. Okay. Now, the key here is we are looking for a survey. Some kind of questionnaire is usually what I'm looking for here. Some kind of questionnaire. And so, number one, said we're going to watch people as they exit the grocery store. We're going to try not to creep them out too much, but we're going to watch them and we're going to see what percent of them use reusable bags, okay? That, for me, is not a survey. That is strictly an observational study, where basically anything that you can do from your lawn chair without getting up is probably an observational study. The next one here, they said we are assigning people into two groups, okay? The moment that you take an active role in here and you divide them into two groups and so forth, this is going to be an experiment. Automatically an experiment, trying to see the effect on a particular amount of sleep and so forth. The next one, we're calling people on the telephone. It's an interesting idea. And to see if they will be voting in the upcoming election. Right there, bingo, bingo, bingo. Winner, chicken dinner. That's where your questionnaire comes into place. We're calling them up. We're asking them a question, recording their response. The last one here, where they're dropping salt cubes into two different liquids to see which one dissolves faster. That's another example of an experiment. Another excellent one to try on our own. In which of the following cases would an observational study be necessary as compared to an experiment study? So go ahead. Great time to pause. Try answering this one on your own. All right. Number one, we're looking at a study of how increased nutrient levels affect plant growth. To me, that's an experiment, because what I'm probably going to do is I'm going to take all the plants I have, I'm going to divide them into two groups or more, and I'm going to basically manipulate the amount of nutrients that each group gets and to see what the impact is. So to me, that's an experiment. The next one, we're going to study how educational levels affect the median household income. I think that's your winner, chicken dinner. observation. Okay, we're just going to do a little bit of studying, and we're going to write, we're going to record what their educational level is, and we're going to record what their median household income is, and just jot it down. Let's compare it to the other ones. We want to look at how vaccine affects the percent of mice that get a particular disease. Probably what we're going to do is divide the mice into two groups, give one of them the actual vaccine, give the other one a fake vaccine, the placebo, and see whether it affects the disease or not. And then the last one, we're studying to see how noise level affects the sleep patterns of some volunteers. Again, we're going to divide the volunteers into two groups. We're going to jack up the noise on one of them and dial it down on the other group to see if it affects their sleep. So I think the common theme with all of these experiments is that there seems to be two or more groups that we're dividing them into. Whereas in number 2, there was no such, groups there. All right, hope you had a great night. We're going to take our time tomorrow in class and talk out a bunch more examples and start to look for some common themes to help us differentiate between the observational studies or not. And the other thing is, go back in your notebook and highlight the cause and effect section. That's going to be another big section tomorrow, and hopefully we'll have some time. I'm going to show you a great article on that 1936 presidential election, and I hope you get a kick out of it. Talk to you tomorrow.